It's incredible to think about. A single drop of a chemical can unravel a huge genetic secret, but that same drop could also cause a really severe burn. The biochemistry lab is a place of just immense power. But with that power, you absolutely need control. So today, we're going to dig into the system that gives us that control. Good, safe laboratory practice.
Okay, so let's dive right in. We all tend to think about the big, obvious risks, right? But what about all the hidden dangers, the ones that aren't so easy to spot? The truth is, every single vial, every machine, every procedure, they all have a potential risk. So the real question is, how do you manage the dangers you might not even see coming?
Well, the answer is a system. It's called Good Safe Laboratory Practice, or GSLP for short. And honestly, the best way to think about it is like an operating system for safety in the lab. It's not just some boring list of rules, it's a whole approach designed from the ground up to protect everyone working in that environment.
And just like any good operating system, GSLP works by making complex things simple. It takes all of those hidden dangers we were just talking about and sorts them into a few main categories. So let's start by getting a handle on what we're really up against. It really all comes down to one number, 4. That's it. There are 4 fundamental types of hazards in any lab. And if you can understand these 4, you're going to be able to anticipate and manage pretty much any risk that comes your way. So here they are, the 4 core hazards. You've got your mechanical and electrical risks, think centrifuges going off balance or faulty power supplies. But for today, we're really going to zero in on the big 3 in a biochemistry lab: chemical, explosive, and infection hazards. Each one of these demands its own unique level of respect and its own set of precautions. Okay, this is where the risks get incredibly personal and very real. We're not just talking about, a spilled beaker. We're talking about severe, life-altering burns from a single drop. We're talking about lung damage from toxic fumes that you might not even be able to see or smell. And then there's the long-term risk of cancer from working with carcinogenic agents. This is exactly why chemical safety is completely non-negotiable.
And then you have explosive hazards. Now, this isn't always about mixing the wrong things together in a dramatic boom. It can be way more subtle than that. For example, something as simple as drying a reducing agent, like zinc powder on filter paper, can actually cause it to spontaneously burst in flames. Or just mopping up some concentrated nitric acid with a cotton cloth can cause it to ignite all by itself. These are the kinds of reactions you have to see coming.
And finally, we have to talk about infection hazards. In a biochemistry lab, you're often working with patient samples, things like blood, saliva, urine, and all of these can carry microscopic, disease-causing organisms. The danger here is literally invisible, which is why following those strict protocols isn't just a suggestion, it is your only real defense.
So, we've identified the hazards. Now what? How do we actually protect ourselves from them? Well, your very first line of defense is what you wear. Let's talk about your personal suit of armor, personal protective equipment, or PPE. And this armor, it's not optional. It is absolutely essential. That cotton lab coat isn't a fashion statement. It's a barrier between your skin and a chemical splash. Those closed-toed shoes, they're the difference between a minor cleanup and a shard of broken glass in your foot. And gloves, they're the only thing standing between you and that invisible world of pathogens and biological samples.
All right, so wearing the right gear is step 1. But step 2 is knowing the rules of engagement, how you need to act and what procedures you have to follow. Believe me, your behavior is just as critical as your equipment. This right here is the foundation for everything else. Before you even think about a rule or a piece of equipment, safety starts in your head, with your mindset. A professional, focused attitude is the single greatest defense against carelessness, and carelessness is the root cause of almost every lab accident. Now, this might seem really basic, but it is so incredibly important. Things like long hair, ties, scarves, even dangling jewelry, they can all get caught in equipment, or even worse, catch fire in an open flame. Securing all these items is a simple, non-negotiable step you have to take before you even start your work.
I want to pause on this one for a second, because it is an absolute. Never, ever, ever use your mouth to pipette anything. I don't care if it's a toxic substance, a biological fluid, or even just water. The risk of accidentally ingesting something hazardous is just way too high. We have tools like automatic pipettes and pipette pumps for a reason, so use them.
Here is another one of those critical rules that you have to commit to memory. When you're diluting concentrated acids, you always add the acid to the water, never ever the other way around. Why? Well, if you pour water into acid, it can generate a massive amount of heat super fast, causing it to boil and splash corrosive acid right out of the container. Just remember the rhyme, do as you oughta, add acid to water.
Glassware seems pretty harmless, but it's a really common source of injuries. First off, always remember that hot glass looks exactly the same as cold glass, so always use a test tube holder. And second, never, ever use damaged glassware. Even a tiny chip or crack can compromise its strength, causing it to shatter when you heat it or put it under pressure.
This is one of those special rules that requires your absolute awareness. Lots of organic solvents are highly flammable, and their vapors can travel a surprising distance. Having a naked flame, like from a Bunsen burner, anywhere near these liquids is basically just asking for a flash fire or an explosion. You always have to be aware of ignition sources. So, you've got your armor on and you know the rules of engagement. But the final piece of this whole safety puzzle is mastering your environment. And this is all about proactive awareness, knowing what's around you before you ever need it. Before you even begin an experiment, you should be able to point to every single one of these items in the lab. In a real emergency, you are not going to have time to start looking for the fire extinguisher or the eye wash station. Knowing where these life-saving tools are is every bit as important as knowing the steps of the experiment itself. And that brings us to the most important question of all. After all the equipment, all the rules, and all the procedures, what's the single most important safety tool in the entire lab? Well, it's the one you bring with you every single day. Your mind. A professional, focused, and aware mind isn't just part of the safety system, it is the system. That is your ultimate defense.